Hi, in this video we look at three examples of functions that can be differentiated by writing them as a sum and difference of power functions. We are giving the following basic differentiation rules. The derivative of a constant is 0. If f and g are differentiable, the derivative of f plus or minus g is the derivative of f plus or minus the derivative of g. The derivative of a constant c times f is c times the derivative of f, and the derivative of a power of x, x to the n, is n times x to the n minus 1. The last one is called the power rule. Putting all these rules together allows us to differentiate sums or differences of constant multiples of powers of x. In particular, we can differentiate all polynomials, but we can also differentiate expressions that have negative or even fractional powers of x. Here are three derivatives that we are asked to find using the previous rules. For all of these functions, the first step will be to write them as a sum or difference of constant multiples of powers of x. In the first example, if we want to differentiate 1 over x to the 4, we first write it as x to the minus 4. So now it is a power of x, and we can use the power rule. The derivative of x to the n is n times x to the n minus 1, so the derivative of x to the minus 4 is minus 4x to the minus 5. Minus 5 as in minus 4 minus 1. So note that when we differentiate a power, the power always goes down by 1. So here by differentiating, we went from a power of minus 4 to a power of minus 4 minus 1, which is minus 5. So that could be our final answer, but it is usually best to write our final answer without any negative powers. Sending x to the minus 5 in the denominator gives a final answer of minus 4 over x to the 5. Note that in this problem, we cannot differentiate 1 over x to the 4 by differentiating the numerator and divide by the derivative of the denominator. This is not a valid rule. There is a rule for differentiating quotient of functions, but that is not what that rule is like. In this second problem, we want to differentiate the product of x with 2x minus 1, all of that squared. So far, we have no way of differentiating product of functions, here x with 2x minus 3 squared, and no way either of differentiating the second factor, 2x minus 3 squared, which is a composition of functions. So right now we need another method which uses only the basic rules that we have seen. The trick is to expand the expression in order to get a polynomial that we can differentiate. We first expand 2x minus 3 squared using the well-known formula a minus b squared, which is a squared minus 2ab plus b squared. And that gives us 4x squared minus 12x plus 9. And we multiply every term by x. That gives us 4x cubed minus 12x squared plus 9x. Then we differentiate each term in the sum. For example, the derivative of 4x cubed is 4 times 3x squared, which gives 12x squared. Overall, we get a derivative of 12x squared minus 24x plus 9. In the last problem, we have a quotient of two functions. Although there is a rule of differentiation for quotients, we have not seen it yet, and the method we suggest here is much faster. First, dividing the numerator by root of x is the same as dividing each term in the numerator by root of x. And note that we can write root of x as x to the 1/2. Then we simplify each term in order to write it as a constant multiple of a power of x. So for instance, the first term is x squared over x to the 1/2, which gives x to the 2 minus 1/2, which is x to the 3/2. Finally, we differentiate each term by applying the power rule. For instance, the first term, once differentiated, gives 3/2 x to the 1/2. I personally prefer not to have in my final answer negative powers of x, so any negative power of x gets sent in the denominator. Finally, I also prefer to write root of x instead of x to the 1/2. And overall, the derivative is 3 over 2 root x minus 7 over 2 root x minus 1 over 2x to the 3/2. Thanks for watching.